And we have to do the questions.
Yes. I'm just checking the questions. Okay, these are exercise problems. Okay, let us do on whiteboard.
Okay, ma'am.
Or you will understand, hear them. You tell.
Ma'am, we can do it on whiteboard.
Okay. So problems which are not solved already, I'll first solve for you, then we'll explain you. Okay.
Okay,
So
ma'am.
right now I'm telling you solved. Because it will take time. So obviously we will do less. So it would be better that which are solved already, I'll explain you on whiteboard, and which are not solved, first I'll solve for you, then we'll explain. Okay.
Okay, ma'am.
So first problem, find Fourier cosine and sine transform of e to the power minus ax. It means fx is given that e to the power minus ax, and where a is greater than 0. It means a is positive, so it will be only negative. Like power
Yes,
will be
ma'am.
negative because a is greater than 0. In case of negative, obviously we will have positive. That is why they are given to us.
Yes, yes,
And
yes.
hence reduce the inversion formula. So, as we have done yesterday, Fourier transform of sine and cosine. So, let us do first problem. This is given that fx is equal to e to the power minus ax, and Fourier transform of sine and cosine. Okay, first they are taking cosine, so let us take. In question they have given to us, so write down cosine first and sine. So we have formula FC of fx is equal to square root of 2 over pi into integration 0 to infinity fx into cos sx and dx. And Fourier transform for cos, and fx is e to the power minus ax. So let us put here. And instead of fx, we are taking e to the power minus ax and cos sx. x dx. Now, by using property of integration, this I'll give you properties of integration also. Okay,
Yes, ma'am.
which they are using. I'll give you all. Okay, formulas, all
Ma'am,
properties.
can you give it by like tomorrow because I'll be trying out these questions.
Sure, 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 sure. I'll give you.
Okay, ma'am.
So 0 to infinity, like when we have product, then we can use these formulas directly. 0 to infinity, e to
Okay.
the power. One second. We have, I'm just checking. We have this formula for e to the power ax. This is formula, okay, into cos bx dx is equal to e to the power ax over a square plus b square into a to cos bx plus b into sin bx. Means by using product rule. Because when we use product rule, then it will be obviously too lengthy. So we can use this
Okay, ma'am.
formula directly. This is formula. But in above transformation, in a state of A, we have minus A. Since
Okay, ma'am.
here of A, we have minus A. And B is equal to small s. Because here, like as they have given to you, A is equal to minus A. Because they are not equal. So we can express this as. Okay.
Okay, ma'am.
That is why I have written this. So now let us use formula 0 to infinity e to the power minus ax cos small s x dx is equal to e to the power minus ax over minus a, we'll use in formula. So minus a square plus s square into a is minus, so let us take minus a into cos s x plus b into sin sx. Sorry, not b. We are taking s in a state of b. Just a second. Small s. Sin sx. Okay. So now let us put this in above transformation. Here we will put this. Okay. Or
Okay.
just for simplify, as we can take one more step like this. E to the power minus ax over a square plus s square minus a into cos sx plus s into sin sx. Now let us put in our transform, okay? So we have
Yes, ma'am.
f. Similarly, you can find for, I'll tell you formula of sine, okay? As we have done for cos, product rule of integration, and then you can do similarly for sine also. Are you getting me?
Okay, ma'am. Yes, ma'am.
Because for fine transformation, we need to know like these formulas.
Okay, ma'am.
Then you will do easily, right? Because in rest of we have this only in transformation. Okay.
Yes, ma'am.
So because this is constant, so nothing more to calculate or nothing more to do. So obviously main
Yes.
thing is these formulas. So Fourier transform for cosine for fx, or we can say for fx is equal to e to the power minus ax is equal to square root of 2 by pi in bracket e to the power minus ax over a square plus s square into minus a into cos s x plus s sine s x. Got it?
Yes, ma'am.
Now let us do for inversion. This is Fourier transform, or see one more thing. Yes, we need to apply limit also, right?
Yes,
Because we
ma'am.
need to apply, this is formula. See this formula of, this is formula of integration. Then we will apply the limits. And now let us apply the limits. So we will get okay. So for infinity, see, when we apply x is equal to infinity here, then
Ma'am, where?
this will be like e to the power minus infinity, right? This will be
Yes,
0.
ma'am.
Okay, then
Yes.
entire term will be 0.
Yes.
And if we apply 0 here, then its value become 1.
One. Yes.
Okay, and for 0, obviously term of sine will be 0 and cos will be 1. So obviously we will get here minus a. That is
Yes,
why
ma'am.
when we apply limit, lower limit, then we have here minus, because upper limit minus lower limit, as you know very well. So this will
Yes,
be,
ma'am.
shall I take this directly? For infinity, we have 0. You want
Yes, ma'am.
one more step or it's okay?
Ma'am, like, just show the step in this one. From next, we'll not skip it.
Okay. And minus a cos s infinity plus small s infinity x and minus e to the power minus infinity will be 0.
Yes.
Minus now put lower limit e to the power minus a into 0 over a square plus s square and minus a cos 0 plus s sine 0. Okay. Or we can
Yes,
write
ma'am.
x also here, okay? Because we have, sorry, in a seat of x, we are using this. Oh, sorry. Yes, just a second. Just remove it. Yes, in a seat of x, we are using limits. So just we can write it as. Now, this entire term will be 0.
Yes, yes.
0 minus. This will be 0 and this will be cos 0 will be 1. So we will have here minus e. And the e to the power, sorry, we have 0. Just a second. My mistake. E to the power 0, then its value will be 1. So it will be minus a, because we will have this minus a and this minus we have outside, over a square plus s square. And finally, we have transform 2 by pi in bracket a over a square plus s square.
Got it, ma'am.
Correct? And here,
Yes.
given that a is greater than 0.
Yes.
Now let us do inversion formula. Okay.
Okay.
Then you will do easily for sine, right?
Yes, ma'am.
Since for inversion we have fx in terms of fc of s, and which is equal to 2 over pi in square root into integration 0 to infinity f c for s into cos s x ds. So fx is e to the power minus ax is equal to square root of 2 over pi and 0 to infinity and FCS, because above is FCS, okay? Above is this, which we have done, right? We can,
Yes, ma'am.
so let us write here FCS, which is square root of 2 over pi and into a over a square in plus s square and ds. Sorry, cos. We have cos s x and ds. So e to the power minus ax is equal to, we have 2 over pi. Yes, we have a also constant. So write down 2a over pi. You got an integration 0 to pi cos s x over a square plus s square and ds.
Yes, ma'am.
So we can express this 0 to infinity cos s x a square plus s square ds is equal to pi over 2a into e to the power minus ax. You got?
Yes, ma'am.
So we have reduced the inversion formula. It
Okay.
means when
Ma'am,
we have, yes,
ma'am, could you please explain me that second line?
which one?
Ma'am, the second line.
This?
Ma'am, is it the formula? No, ma'am, above that. After the integration 0 to infinity, why have we written under root 2 by pi again? Like it's the formula or what?
See, we have used value of FCS. This,
Okay.
which we
Okay, okay,
found
okay, okay.
above. which we found above this is.
Yes, yes, yes. Yes, yes,
Okay.
yes. Okay, ma'am.
Yes.
Got it, got it.
So in this way, you can do for sine also. Okay.
Yes, ma'am.
And let me check further what we have. Just few seconds. Okay, so next question based on using password identity, evaluate this. Okay.
Yeah. Ma'am, you're gonna tell me about that integration formula for sine.
Yeah, sure, sure. Just give me few seconds.
Yes, ma'am.
Sending you, okay?
Yes, ma'am.
Because for indefinite integration, we add here constant also. Here I'm telling you because write we have written for a with limits earlier. That's why I didn't add here C. That constant, remember, for indefinite
Yes,
integration.
ma'am. Yes,
So
yes,
we will
yes.
have this also, okay?
Okay,
Because we
ma'am.
are doing for indefinite, that is why we didn't add. But in formula, we will
Yes.
add. Okay, I have
Okay.
sent you. So, want to do more?
Yeah, we can do this question, ma'am. Possible identity one.
So you can do yourself.
No, ma'am. Can we do the first part? I'll do the second part.
See, I'm telling you what you need to do. See, you have formula. I'm explaining you how can you do.
Okay.
Just a second. See, in a state of cos bx, we have here sine a, sine bx. Okay. So we will take
Yes, ma'am.
formula this. I'm telling you, or the integration. I'm telling you that part of integration. Okay.
Okay, ma'am.
We have. Okay, I'll tell you that also, which you need to do in transformation. So Fourier transform for sine. This is Fs for fx is equal to square root of 2 by pi. Okay. And integration 0 to infinity fx sine S x dx. We have done yesterday this formula, right?
Yes, ma'am.
This
Yes, ma'am.
changes of that, this C of sine Sx only.
Yes.
So let us do. Yes, nothing is changed. So we can write this f as instead of fx, we can write it as is equal to square root of 2 by pi 0 to infinity fx is e to the power minus ex into sine sx. And by using formula of integration, we can find, I'm taking directly, okay? Since
Yes, ma'am.
0, this integration e to the power minus ax into sine s x dx is equal to, let us use formula now. It will be instead of a, we are taking minus a. And inside we will take a minus a because a is minus. Sine s x minus s cos s x. Because we are doing for definite, so we will take it as. You got?
Yes, ma'am.
So for infinity, similarly, first term will be 0. Okay. And here
Yes, ma'am.
in previous, we have minus a in numerator. But see, here we have minus s. In previous, we have
Yes,
here
yes.
minus a, but here instead of
Yeah,
minus
first,
a, we
first.
have here s.
Yeah.
Because for
Okay, ma'am.
infinity, this will entire term will be 0, but for 0, this term will be 0. So for 0, it will be
Yes, ma'am.
minus s. So I'm taking directly, okay? Now you
Yes,
got?
ma'am. Yes, yes, yes.
It will be after applying the limit, we have first term 0 minus, then we have here 1 upon a square plus s square into minus s. Then we have s over a square plus s square. Now we can find CF as for e to the power minus ax is equal to square root of 2 by pi into s over square root of, sorry, a square plus s square. You got?
Yes, ma'am. Got it.
Yes. So now you can do for inversion. Okay.
Yes, yes, yes.
Instead of uh, this, we will write here s over a square plus s square. Okay.
Yes, ma'am.
Yeah. So just backset it and I'll give you more formulas of transform, which you can use directly in terms of A
Okay,
and
ma'am.
S. Okay. I'll give you more.
Okay, ma'am.
Yes. All right.